Let's take a look at exercise 2. We have a small cuboid. We have a box with a rectangular base of length 3x centimeters this way and x centimeters the other way, and the height is y. The sum of the length, width, and height is 12 centimeters. Write down an expression for y in terms of x. So we know that the sum of the length and the width and the height is equals to 12, and we should write down an expression for y in terms of x. So we just sum these two together as 4x and move this over on the right hand side and change sign. So this is the answer on exercise A. And then the volume of the box is v cubic centimeters. Find an expression for v in the terms of x, and here you should start with a formula for the volume of a box like this, and that's the length times the width times the height. So this will be 3x times the width, which is x, times the height, which is y, which is 12 minus 4x. So you will get 3x squared times 12 minus 4x, which will be, I'll just take this first, which is minus 12x to the power of 3 plus 36x to the power of 2. So there we have an expression for the volume in terms of x. And then it says find dv divided by dx, which actually means like this. If you look in the book, you will see that this is a different notations for the derivative. So you're going to just find the derivative of this function in exercise C. And why do we find the derivative? That's because we want to find the maximum point, and to find the maximum point we have to solve this equation, find out when the derivative is equals to 0. And it says justify your answer, which means that you have to, after you have solved this equation, you have to show that this is a maximum point and not a minimum point or a terrassepunkt. You have to show that it's a maximum point. And if you remember from exercise 1, there are different ways of showing this. You could draw a sketch of the derivative, the graph of the derivative. You could use the second derivative, or you can also draw some sine lines if you want. And then you should evaluate the maximum volume, which is find the volume. We can use the function we made here and just put in the x value of the maximum point. So put in the x value of the maximum point and you will find the volume. So that was exercise 2.